欢迎。
早上好。Every year I learn a new Chinese word. The neural network of my brain is very slow. What's the clicker? Here. So I'm a cultural historian, but my background is in artificial intelligence. That's me in 1987. I hope I haven't changed much. I'm going to tell you my opinion of the state of artificial intelligence, and I'm going to say it in 10 points because I think artificial intelligence is not one discipline, it's a confederation of disciplines. And for each one, I will tell you this is a state, but there are limitations. So I'm going to tell you, talk a little bit about the brain, vision, robots, language, learning, and then really briefly about common sense, morality, creativity, consciousness, and then I will close discussing a little bit the world in which we live. One thing I have to tell you at the beginning, I wrote this book directly in Chinese with a Chinese journalist because I don't write Chinese. And one day she asked me, "Are you afraid of artificial intelligence?" And I replied, "I am afraid that it will not come soon enough." And I hope by the end of this presentation you'll understand why I think that way. So let's start with the brain. These are brains of animals. And from even before the computer was invented, we were already thinking of building a machine that emulates the brain. That article appeared 17 years before the first computer. And then when we built the first computers, we called them electronic brains. These are some of the early computers. And I like these pictures because they show that the original software engineers were all women. Well, that's a different presentation. Anyway, that's the electronic brain, and that's the human brain. And again, the publicity of the early computers, they talk about the electronic brains. Can they think? That one, Giant Brains, is the first book published on electronic computers. And it's called Giant Brains. That's a digital neuron. Today it's a little more complicated, but basically that's a digital neuron. And down there is the biological neuron in your brain. And this is the way digital neurons communicate. Again, today is a little more sophisticated, but it's basically the same thing. Right? And this is the architecture of the computer, and that's the architecture of the brain. Very different, right? Now, 2006, 2007, something important happened in artificial intelligence. I think these are the gentlemen who really started a new wave of artificial intelligence, what we call deep learning, the neural network that has many layers, different techniques, but same result. And that was impressive, and to some extent it was based on the structure of the brain. And since then, we've had a lot of success stories, sensational announcements, and the latest is, of course, AlphaGo. When Google does it, everybody talks about it. So just to focus on AlphaGo, in my book I analyzed several different cases, but just to focus on AlphaGo, using the paper that they published, I tried to calculate how many watts AlphaGo consumes, and I came up with 440,000 watts. Your brain consumes 20 watts. So what can AlphaGo do with 440,000 watts? One thing, play way cheap. What can you do with 20 watts? A lot of things, including listening to me right now, which is actually very difficult. So who is more intelligent? The quote-unquote machine that uses 20 watts to do an infinite number of things, or the machine that uses 440,000 watts to do just one thing. So when people ask me what is going to be the next breakthrough of artificial intelligence, what's the next big thing coming in artificial intelligence? In my opinion, it will come from neuroscience, from the study of the brain. We know very little about the brain. And there are some recent initiatives that could be very important to discover more about the brain. The United States launched the Brain Initiative, and the European Union launched a similar initiative in 2013. And I compare them with the Apollo program to go to the moon, with the ARPANET, which is now called Internet, and with the Human Genome Project. These are projects that potentially can tell us a lot more, and that knowledge can result in much better technology. So that's the launch of the Brain Initiative in 2013. So, number two, vision. As I said, starting pretty much in 2012, we've had a number of very impressive success stories. This is one of the first ones that was widely publicized when a joint team, Stanford and Google, implemented this neural network that started recognizing cats in videos. And that was, of course, very impressive. Now, since then, the technology originally developed for linguistic applications, has been applied to more and more sophisticated recognition of images. So in 2014, two teams, one at Google and one at Stanford, published papers that showed how neural networks are now capable of recognizing what is happening inside the image, not just recognizing an object. So that's probably one of the famous pictures that was publicized, young people playing frisbee. And that was impressive. And at the same time, Fei-Fei Li at Stanford achieved similar results. In 2014, the Google blog had this picture that shows some of the results. You can see there's one, the second one says 2 dogs playing in the grass. Well, it's 3 dogs, but that's pretty impressive. A lot of humans could make the same mistake. But I want you to focus on the one that I circled, and we'll discuss this a little later. It's the image of a street sign, and it was recognized by the neural network as a refrigerator full of food. Now, 2-3 years ago, I was giving a similar presentation, and I was telling people the application I want to see of deep learning is about medical images. When I visited Philips, they told me that they have 135 billion medical images that have been seen by only one doctor. They take an image of your arm, or your leg, or your lungs, and one specialist looks at it. And I was saying, I want deep learning to scan these images all the time, every day, based on the latest scientific knowledge. That was my dream application of deep learning. Well, in 2017, I'm happy to say that this has become business. And just a few weeks ago, there were 2 papers. The first one was published by Sebastian Thrun's team at Stanford, and it's about a neural network that can recognize skin cancer from the image. And the other one is in England, neural networks that can predict heart attacks. These are things that can save the lives of millions of people. So that image up there, the neural network thinks it's a refrigerator filled with food. That image was recognized as gorillas. That image was recognized as a bus. So what is wrong with these mistakes? They tell you the neural networks makes fewer and fewer mistakes. But I want to know what the mistakes are. And these mistakes makes you laugh. And there's also some theoretical background. I mean, this has been proven. Those two images are the same image, right? It's a dog. Well, no. One has been manipulated a little bit with those perturbations. And that was enough to fool the neural networks. So we know that there are limitations to machine vision. And last year, in the timeline of artificial intelligence, we should add the first person to die in a self-driving car accident, not just the success stories. And always remember, put things in context. It's great that a machine can recognize a cat, but how long does it take for a mouse to recognize a cat? So still a very big difference in biological vision and machine vision. Number 3, robots. These are the earliest walking robots, and these are some of the most famous ones. They have legs. But if you look at the robots that are actually used today, they don't have legs, or they have 4 legs. So that's a problem that is still not solved. But I solved it. I can walk. You can walk easily. And also grasping objects. You see robots, videos of robots that do amazing things with their hands. But look down below, and sometimes it tells you this is 24 times the speed. Not only that, but the most famous of these research projects was the Google project. And last year, Google decided that it's not launching that robotic arm. And you saw many videos probably of that amazing robotic arm. And again, in the timeline of AI, we should also mention that last year a robot injured a child in a shopping center. And if you want to see the state of the art in walking robots, I recommend 2 videos. You can find them easily on the web. The video of the DARPA Robotics Challenge and the video of the RoboCup. These are 2 of the major competitions for robots. And you can see, because usually they show you the robot that does really well. But if you watch those videos, you will see robots that cannot get out of a car, they fall. And robots that try to play soccer and they go, and they, boom, they fall. Okay, that's the real state of the art. Okay, this. Now, number 1 question I get asked when I talk about robots: will they steal our jobs? I am not an economist, but I found these statistics. This is the density of robots in different countries. The number 1 in Europe is Germany. The number 1 in Asia is Japan, followed by South Korea. And the number 1 in the Americas is the United States. And then I found these numbers about unemployment. Which country has the lowest unemployment in Europe? Germany. Which country has the lowest unemployment in the Americas? United States and Canada. And which country has the lowest unemployment in Asia? Japan. So I don't see it. I don't see the correlation between robots and unemployment. I actually see the opposite. Anyway, language. Again, impressive progress. We now have a live translation from some languages. using technology that is well understood. And of course, speech recognition is getting better and better. The machine can finally understand my accent. And it's getting easier to build chatbots. There's a yearly prize called the Loebner Prize for the best chatbot. And if you try this, these systems, you will see how much progress there has been. And it's getting easier and easier to build your own chatbot. But, again, there's always a but. But last year, Microsoft had to withdraw its new chatbot because it started behaving like a violent racist. And we don't have any system that can understand a conversation like this, ask questions, reply, have arguments with me, ask me questions. Learning. Machine learning is an old field of artificial intelligence, and recently the big success stories have come from reinforcement learning, as you have seen in previous presentations. The most famous success stories of reinforcement learning is AlphaGo. What is the problem? But, yes, there is progress, but the progress depends on the large data set. So all the speakers here who emphasized big data, absolutely right. All the success stories of AI come after somebody built a huge data set. So the big success stories are in red, and in blue you see the data set that they used. First, somebody built a large data set, then you have a success story that the media talk about. And there's still a fundamental difference, even when we say learning. Now, we humans, we see many dogs and eventually learn what a dog is. So I can ask you a simple question. Can you draw a dog on a piece of paper? And most of us just draw something. That's my attempt to draw a dog. I'm not an artist, but 4 legs, it looks more or less like this. That's a sign that I have learned what a dog is. And it's very difficult for machines. Machines can be very good at recognizing a dog, but you cannot usually ask, can you just draw what a dog is like? And there is progress. There's new technology coming. This is a very impressive paper, possibly the most impressive paper I've seen recently, because those images are images of furniture, but images of furniture that does not exist. It's the machine that has generated those images. So anyway, there's progress, but still a long way to go before we can say that a machine learned something. Learning something means you know what to do with it, you know how it looks like, you know what it is. Okay, just recognizing that a bottle is not enough to say you learn what a bottle is. Now, common sense. This is one of the big research topics of the future. That mistake, a refrigerator filled with food. Now, when I see that mistakes, I laugh. Why? It's not just it's a mistake. We all make mistakes. But it's a silly mistake. It makes no sense. That's not in the kitchen. Okay? Where's the food? So, neural networks don't make a lot of mistakes, but when they make mistakes, those are mistakes that sometimes we cannot tolerate. And to explain what I mean by common sense, I use this example. Last year in England, these children formed this arrow. The police on a helicopter were chasing criminals. The children knew where the criminals were. Now the children had to help the police catch the criminals. So first of all, you have to know police, good, criminals, bad. I want to help the good ones. Second, the helicopter cannot hear you, but they can see you. And what message can you send to the helicopter? Visual message. The arrow. What does the arrow mean? Go in that direction. Nobody told the children to do this. The children did it spontaneously because human beings have common sense. Now briefly about some other things that are typical of human beings. Morality. How can we make sure that machines will know the difference between good and bad? For example, the Microsoft Chatbot. It is bad to be racist. So there's different ideas, but we're just beginning. There were two important conferences, two large conferences this year about this topic. And what about creativity? Well, something happened last year. Google showed us these wonderful images made by neural networks. And as you probably know, we have a book of poems made by machine. I organize events in the San Francisco Bay Area, and a few weeks ago, my friend Maya Ackerman, she's the one singing, performed music composed by two algorithms. Mabel writes the lyrics, and Alicia writes the music for the lyrics. Impressive, right? It's actually not too difficult. What is difficult is criticize that art. What is difficult is to have an opinion about that art. Everybody asks me, will robots be conscious? Will machines be conscious? Well, there's different theories. First of all, we don't know what is consciousness. Why am I conscious? Where does it come from? But there's some theories, and Professor Tononi has a theory that is very popular. That's phi, and it comes out of integrating information. So, I don't know, maybe some days robots will be conscious. But I wonder why we're asking the question. Because every year we kill 60 billion mammals, birds, and fish to eat them. And I don't hear people asking, is the cow conscious? And to me, consciousness is when you realize, when you laugh. You see a mistake and you laugh. Not just, oh, it's a mistake. It's a silly mistake. So you laugh, you tell your friends, hey, look at this mistake. So I want to close with a few slides about our world. So first of all, don't be afraid. So the message is, don't be afraid of superhuman intelligence, okay? First of all, superhuman intelligence has always been around us. It's everywhere. My favorite example is the bat. The bat is an animal that can fly in the dark very quickly, very high speed, capture insects. It can even land upside down on the ceiling. Can you do that? That's superhuman intelligence. And we already built objects that can do things that no human being can do. Think of the clock. Right now I'm walking here to check the time. I still have 5 minutes and 43 seconds. 42, 41. Can you do that? Can you tell me how many minutes and seconds I've been speaking? The clock is a superhuman machine. It can do it. So, it's not so dramatic. In fact, that's the history of human civilization. Humans are messy. The human world is very chaotic, very complicated, sometimes hostile. And we build technology from ancient times to deal with a world that is so complicated and chaotic. And in fact, at Stanford, we study these things, and they have a scientific name, wicked problems. And this is how my friend Bob Horn visually represents them. And this is something that we hope that artificial intelligence comes very soon to help us solve these problems. Problems like healthcare or pollution or climate change. So this is my lab. I had to show at least one picture of my team at Stanford. So the message is, don't be afraid of what is coming. And to show you our world, where we live today, I went to the subway station in Hangzhou early in the morning, where there's nobody. Very difficult in China to take pictures with no people around. And I took pictures of the subway station. So there's a machine that sells tickets. There's a machine that takes photos. There's a machine that sells food. There's even a machine that sells toys. There's a machine that checks my luggage. There's a machine that checks my ticket. How do I go up and down? There are machines. So I was one of the few human beings in that station. I was completely surrounded by machines. That's the world in which we live. If you read my book, you will realize that there are other technologies that, in my opinion, can actually be more disruptive. So I don't rank artificial intelligence as the #1 disruptive technology, and not even as the #1 business opportunity. You really have to be realistic at what machines can do, and especially what machines cannot do. You cannot trust a self-driving car that doesn't have common sense. So, conclusions. We need artificial intelligence. I want that system, an app on the smartphone that tells me immediately, is this skin cancer or not? So we need artificial intelligence. We have very big problems to solve in this world. And I think the society of artificial intelligence will create jobs that today we cannot imagine. That's the history of technology. Every new technology kills some jobs. It's very difficult to predict which jobs get created. Just imagine what happened when we invented computer and we coupled it with communication. We got the smartphone that created millions of jobs. Yes, of course, computers also killed a lot of jobs, but we created millions of jobs to build these kind of things. This is a Xiaomi. So I think that actually humans should be look forward to that age. It's not that we will have less intelligence. We will need more intelligence, because the world of artificial intelligence, just like every previous technology, requires higher skills. So actually, human intelligence will be more important, as it has always been, as we went from the caves to the medieval cities, to the Industrial Revolution, to the computer. People had to be smarter. That's why you study 10, 15, 20 years in university now. The future always surprises us. Thank you very much.
Thank you.